C program for GCD, greatest common divisor of two given integers using recursion. Recursion is a repetitive process. A function is called by itself is called recursion. In this, a function will only called by itself. But whereas in non-recursion, loops will be there. In that's the iterative statements. Okay, only statements will be iterated. In non-recursion, we use loops. In recursion, we use only function. A function is called by itself. You see here in this recursion, function, if we call the function, then control will enter into the called function. Then this is the same function name GCD. Okay, this function is called by itself. Okay, this is the recursion. This function is called by itself is called recursion. Okay, in this recursion, whenever we call a function, the value will enter into the stack, that is the push. If we return a value, then that value will pop. Okay, push and pop. Whenever we call, the value will push. Whenever we pop, the value will come out from that stack. So in the recursion, it takes some process compared to non-recursion. Compared to non-recursion, recursion will take some time. So in non-recursion, execution will be fast, whereas in recursion, execution will be a little bit slow. Why? Because we push the values and pop the values. For that, it takes some time in recursion. Whenever we call, we push the value into the stack. Whenever we call, we push. Whenever we return, we pop the value, we take out the value. Pop means take out from the stack. So in the recursion, this push and pop operations will be done in the stack, okay, in the main memory. This is the memory management. Okay, you see here GCD of two numbers using recursion. A function is called by itself is called recursion. Now we are going to find GCD of two numbers. Okay, for this, you see here, I will explain the procedure. You see here, if I give numbers 20 and 15 for the P 20, for the Q 15. If we give 20 and 15, 20 by 15 only possible, but we cannot give 15 by 20. Okay, 15 1 is 15, 5 is the remainder. Then we take this value here, 5 3 is 15, remainder is 0. Okay, next this is the Q, this is the P. Okay, whenever Q is 0, you see here Q value, this is the place of Q, this is the place of P. Okay, whenever Q receives 0, whenever Q place becomes 0, then we stop the process. Then ultimately, by default, okay, the 5 is the answer. This is the P place. This is the GCD value. Okay, so here you see here, about to the main, we write a function, that is the prototype or signature of a function. Why we write here prototype? About to the main, we write prototype. Okay, this is not a prototype. About to the main, we write prototype. What we write here, that is the prototype. Okay, this is the prototype. Here we have to write about to the main. Okay, why we write prototype? This is the prototype or signature of a function. Okay, here this prototype or signature of a function we use for the purpose of compiler. This program compiler, okay, will know which function we are using in this program. So we are going to instruct to the compiler regarding usage of our function to the compiler. We are instructing to the compiler. What we are instructing? We are going to use this function. This function will return a value. What it will return value? Integer value. So for that purpose, we have to write about to the main. Okay, we write the here only. Here we cannot write, we have to write here. Okay, about to the main we write prototype of a function. Why we write? To instruct to the compiler we write. Regarding usage of this function, we instruct to the compiler which function we are going to use. GCD. How many parameters? 2 parameters. Which type? Integer type. Okay, here we write return type, function name, type is the data type, function name, what's our function name? GCD. Okay, next type of variable, type, that variable, how many types? 2 types. Either now you can write like this also, no problem, just you can mention type also, no problem, or you can write this int p and int q, like this also you can write, no problem. Okay, so this is the signature or prototype of a function. Unless we use, we will get prototype error. Okay, right. Next we are going to give 2 numbers. It will ask to enter 2 numbers. We will read through keyboard A and B. We store in the main memory at a particular address for A and B. Now we store in main memory the values. Now we call the function, calling function, call function, invoking function, declaration of a function. Okay, whenever we call, immediately control will come into the called function. Okay, these are actual parameters or arguments. These are formal parameters, okay, or dummy parameters. What we pass the values here, that values will be copied into the called function. Okay, if I give 20 and 15, okay, 20 for A, 15 for B. Okay, 20 will receive by P, 15 will receive by Q. What's the Q value? 15. You see here, what's the Q? If I give 20 and 15, the values will copy here, 20, 15. You see here, 20 and 15 I will give. Is 15 equal to 0? No, not equal to 0, 15. Okay, next we will come to else, return. Whenever we call, we push the value. Whenever we return, we pop the value from the stack. Return GCD of Q comma P mod Q. What's the Q value? Here 15 I gave now. You see here that 15 will come here. What's the P mod Q? 20 by 15. 20 by 15 is 5. So 15 and 20 modulus 15. 15 and 5. Here 15 and 5 are the values. Okay, that 15 and 5 we will call this function once again. Okay, recursive function. What's the recursion? A function is called by itself. Okay, first from here we enter here, next we called by itself. Okay, now what are the values? 15 and 5. Okay, 15 and 5. Is 5 equal to 0? No. Okay, next you see here 15 and 5. What's the Q value? 5. That value will come here. You see 5. Okay, right, 15 and 5, Q value 5. 5 will come here. Okay, P modulus Q. Okay, 15 modulus 5. 15 modulus 5. You see here 15 modulus 5. What's the answer? 0. Okay, here 5 comma 0. Okay, so now we will once again this function will called by itself. So here 5, here 0. P is 5, Q is 0. Is what's the Q value? 0. 0 equal to 0? Yes, return P. Okay, P is the final 5. You see here 20 and 15, Q value will come here, P mod Q. P mod Q. What's the answer? 5. We pass this value to here, 15 and 5. Q value come to here, that Q value come to here. That's the 5, 15 modulus 5, 0. Okay. you see here. Then once again we pass these values. Okay, 5 and 0, 5 and 0, we pass 5 and 0, we pass here. Now this is the q value. Whenever q is 0, we return p. Okay, so whenever we call the function, push the value into stack. Whenever we return, we pop the value, we take out from the stack. So in recursion it takes some time compared to non-recursion. It's a late process for execution and compilation also. So like that, return p means return, this is the p, this is the q. Till we get 0 of q, we have to do the process. Whenever q is 0, we have to stop, we have to return this value, return p. We return that 5. This is the body, this is the head. That 5 will return to here, that 5 will be assigned to result. Next to GCD of %d and %d. A, B result. What's the A? 20. GCD of 20 and 15 is 5. That is the answer. Okay, you see here 20 and 15. Next time 15 and 5. Next time 5 and you see here PQ. Okay, Q will come here. P modulus Q 5. Q value come here. P modulus Q is 0. Till Q is 0, we do the process. Whenever Q becomes 0, we stop the process. We return the P value. That is the GCD. GCD of 20 and 15 is 5. Okay, you see the program. You see here. Enter two numbers. Function call. Whenever we call the function, control will come into called function. Next, we do a function is called by itself. You see here a function is called by itself is called recursion. This is the recursion, repetitive process by itself of the function. Okay, this function is called by itself only, so it is called recursion or recursive procedure or recursive function. Here GCD will act as a recursive function. Why? Because this function is GCD is called by itself only. Okay, now we are going to compile and execute a program. You see here 0 errors. Enter two numbers. We can give 20 and 15. What is the GCD of two numbers? You see here I gave two numbers 20 and 15. Now I got the answer 20 and 15 is 5 for the GCD of 20 and 15 is 5. This is the output of this program. Okay, once you do this program, you see here this is the program of GCD. Two numbers are required. This is about the main is prototype, return type, function name, type and parameters. Next we enter, we call the function, control will enter into called function. Till q is 0 we do that, then we come back to the GCD, then we assign the value result. Okay, whenever it returns, that will go to head of this function. This is the body, this is the head. The return value go to head, head will assign to result res. Here we will display that res result is 5. 20 and 15 is 5. The result 5, we display that. Okay, this is the program for GCD of two numbers using recursion or recursive procedure. Okay, if you like it, please share and subscribe. Thank you.